In this video, we're going to apply a /26 subnet mask to an IP address and identify what happens to the networking space in that particular system. We're going to use the same example address that we've used before, 192.168.100.10. And take a look at our subnet mask this time, /26, 255, 255, 255, 192. Hey, first things first, where's that number 192 come from? It comes from the fact that we're now using the 2th high order bits in the 4th octet towards the network, and we have now shrunk the size of the network by one more digit. So, that being said, if we look at 1 and 1 there, and we look at the number 192 here, that is constituted by the highest order bit, that is 128, plus the second highest order bit, 64. And we can do the math in our heads, equals 192, and that's where that number comes from. Great. Why is it a /26? Because it is 26 digits in a row. Now, what does that leave us for a host? Oh no, now we're down to 2 to the 6th power of digits that are left. 2 to the 6th power of digits, 2 to the 6th power of digits. And if we look at those combinations of numbers, that would give us 6 zeros in a row. 1, 2, 3, 4, 5, 6 zeros equals 0. If you pair that with 6 ones, 1, 2, 3, 4, 5, 6, and you added those numbers together, which would be 32 plus 16 plus 8 plus 4 plus 2 plus 1. Trust me when I tell you, you would get to 63. And that would mean that the number 10 would now be in a network. That would be 192.168.100. I guess I could write the network ID up here. Net ID is going to be 192.168.100.0. And the broadcast ID would be 192.168.100.63. Great. All right, so that's pretty cool that we've shrunk the network down by half again. We were at /24, we were at 256. At /25, we were at 128. At /26, we're now down to 64 addresses per system. Now, here's the thing. How do those actually break out? And if you look at the numbers to the left of where we've drawn the line into that 4th octet, you can see that we have 2 digits here that make up the network portion in that 4th octet. And in this particular case, they're both zeros because the number 10 doesn't have a 1 in the 128 or the 64 position. But if say, the 128 or the 64 position did have a 1. So, for instance, if we look at this here and we just kind of say, okay, well, let's make a quick change here and let's just do this right there, right? Those are both zeros for that particular system. But if we went to another system and it would say the address was maybe with a 0 and a 1 in that position for the highest and lowest orders, or a 1, 0 in that position, or a 1, 1 in those positions, in the 7th and 8th positions in that 4th octet, then your addressing space would look a little bit different. So it would be 0, 1, and then the host bits would be 0, 0, 0, 0, 0, 0. And this would equal 64, because there's a 1 in the 64 position. And 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 127. Trust me on that one. The next one, a 1 in the 128th position, the 128 position, with 6 zeros, would give us a value of 128. And 1 0 with 6 ones would give us another network that would go up to, and trust me on this, 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. It would be 191. And 2 ones in the top 2 bit order positions. 192, we already know that one, with 6 zeros, equals 192. And 2 ones there with all ones equals 255. So some people would say, well, that makes 4 networks. Sometimes that's a little confusing. For the number 10, it's still the same network. This size of the network has just gotten smaller. But in the same space where we used to have a /24 and we had 1 network, we do have 4 networks now. We have a network that's defined by the decimal value 0 through 63. We have another network that's defined by the decimal values 64 through 127. We have a third network in the fourth octet between 128 and 191. And we have a network in the fourth octet with 192 to 255. Obviously, the first three numbers still have to be 192, 168, 100 in order for it to be the same network. But we've taken that fourth number, that fourth octet, which was just one value, just all host, and we've now broken that same space down. It's still 256 total addresses, but we've now made 4 equal-sized networks out of them, each one of them 64 addresses in total.